Alright, hello there and welcome back. We are starting a new unit. This is Schedules and Parameters of Reinforcement in Applied Behavior Analysis in Early Childhood. This is going to be video part 1, and up until this point we've talked quite a lot about reinforcement and its application in differential reinforcement. We've talked about different types of reinforcers: conditioned, unconditioned, positive reinforcement, negative reinforcement. We've talked about how with the procedure of differential reinforcement you can establish discriminative stimuli, and also you can produce response differentiation. So it depends on whether the reinforcer contingency is based on response properties or stimulus properties. And what we haven't talked about yet is how reinforcement can be arranged to be produced by specific responses at specific times to produce specific patterns of responding over time. So what I'm talking about there are schedules of reinforcement. They specify which response will be reinforced and when. And we're also going to talk about, in this unit, parameters of reinforcement. Parameters of reinforcement are more qualitative. So, for example, the magnitude or intensity or quantity of reinforcement. And those things can be adjusted also to change an organism's behavior or the pattern of responding over time. So that's what we're going to cover in this week's unit on schedules and parameters of reinforcement. Here are our objectives. Identify important figures and a brief history of schedules of reinforcement. Identify the primary apparatus historically used to study schedules of reinforcement, and then list the defining features of that apparatus. Define schedule of reinforcement, and list and identify critical and variable features of schedules. Then define and discriminate between continuous and intermittent schedules of reinforcement, and identify the schedule of reinforcement used to teach new behaviors. In this first video part, we are going to largely focus on the first two objectives. Objective number 1 is to identify important figures in a brief history of schedules of reinforcement. The first is Charles Foerster, and the second is B.F. Skinner. And there were other important people who contributed, or who were significant in the history of schedules of reinforcement, but Charles Foerster and B.F. Skinner were particularly important figures, if not the most important or the most influential. And together, Foerster and Skinner published this seminal book, Schedules of Reinforcement, in 1957. Probably these days a lot of people have not read Schedules of Reinforcement from front to back. This is this book is so dense with data that it's difficult for most people to get through it. But it's a gold mine. It's a gold mine of knowledge about how contingencies influence patterns of responding over time. And this was a landmark text in behavior analysis. So if you get a chance to read Schedules of Reinforcement, I would encourage it, and to try to chip away chapter after chapter, if not over several months, several years, over a career. Chip away at this. I think you'll be glad you did. So schedules of reinforcement was the first and biggest collection of data on the control of behavior by reinforcement schedules. And again, I'm going to be talking about reinforcement schedules mostly just by saying the words, but we're going to get into detail later in subsequent videos about what reinforcement schedules are, and then we're going to list and identify some types and so forth. Schedules of Reinforcement, the book, was largely based on data collected during 4 years of intensive 24/7 experimentation with pigeons. And the experiments examined how reinforcement controlled response repetition. That is, how arrangements of certain contingencies altered the probability that the pigeon would repeat a response, such as pecking a key light. And in this research, Furster and Skinner used repeated measures of responding. Responses were selected for their convenience. In other words, they studied pigeons picking key lights because that was an easy behavior to reinforce and measure. And then 3, automated measurement using cumulative recorders. Of course, the automated measurement is critical here. That enabled them to conduct these 24/7 experiments and collect data on responding continuously over large periods of time. So, objective number 2 is to identify the primary apparatus historically used to study schedules of reinforcement and then list its defining features. So the primary apparatus is the cumulative recorder, and that's what's depicted in this picture here, borrowed from Littall, 2004. This is a Ralph Jobrans Company Model C4 cumulative recorder. Okay, so this at the time was a fairly common version of the cumulative recorder. The cumulative recorder was initially developed in the 1930s by B.F. Skinner, then perfected in the 1950s, and was mass-produced in the 1960s, according to Littall. And we've talked about the operant chamber, but in earlier classes when we've talked about it, we've really just focused on the fact that the organism is in a box, pressing a lever or a key light, and having food dispensed. And sometimes, sometimes there's a light that signals the availability or unavailability of the reinforcer. We've also talked about the grid on the bottom of the operant chamber sometimes can be used to study the effects of negative reinforcement by using electric shock and so forth. So we've talked a lot about the operant chamber. But we haven't talked about is how responses within the emitted in the operant chamber were recorded and graphed and observed over time. All right, so with the operant chamber, the cumulative recorder is very much symbolic of Skinner's approach to studying behavior, and the operant chamber and the cumulative recorder are linked in that way. They're used together. The cumulative recorder produces a cumulative record. So the device in the picture is the cumulative recorder, but the lines drawn on the paper there, that's the cumulative record, or that's the graphical display of the organism's behavior that occurred during a session. Data collection is automated with the cumulative recorder. The rate of responding is the basic datum. So that's what the recorder displays. It displays the rate of the organism's behavior, specifically the behavior of interest in the study. So not all of the organism's behavior, but just the behavior being studied, for example, pecking key lights or pressing levers. And the slope of the line represents the rate of responding. So a steep slope indicates a high rate of responding. A less steep slope represents a lower rate of responding, and then a flat line represents the absence of responding. Responding is no longer continued, the organism is not engaging in the target behavior. Yeah, a flat line indicates that responding has ceased. Okay, so that's just a general overview. We're going to get into more detail here about the history of the cumulative recorder and cumulative record and the major impact that the cumulative recorder had on the field of behavior analysis. Alright, let's take a look. So we have the same picture we saw on the last slide on the left here. And on the right are some samples of cumulative records. And again, these are borrowed from Littall 2004. The cumulative recorder was one of the earliest and most important devices used in the experimental analysis of behavior. And Ken and Littall said that the cumulative recorder did for behavior analysis what the microscope did for biologists, which was to provide a way of observing some aspects of behavior that would have been impossible to see without the technology. In the typical experimental arrangement, the cumulative recorder consisted of the following features. First, with each response of the organism, a pen stepped vertically across a roll of paper. That's what you can see here, indicated by the green arrow. You see a pen here, and the pen is marking the paper as the paper rolls out with the passage of time. 2, the pen pipped or moved downward or deflected horizontally and appeared as a hash with each reinforcer delivery. So for example, here in this cumulative record, each of these lines downward here, those are called pips. They indicate that a reinforcer is being delivered. Similarly, in this graph, the lines that go to the left, right there, those are called hash marks. They also indicate the delivery of the reinforcer during the session. Okay, so number 3, when the pen reached the top of the page, it reset by returning to its original position at the bottom of the page. And that's what this arrow is pointing to. So the paper, as time is passing and the session is ongoing and the organism is responding, the paper is rolling downward and the pen is moving along here, recording the organism's responses, and then when it reaches the top of the page, it would reset back to the bottom and then go up, up, up with each response. And then lastly, another pen moved up or down to mark the occurrence of other events of interest, including specific responses or stimuli. And that's what we have here indicated by this green arrow, another pen making additional markings here at the bottom of the graph. As a result of the movements of the pen corresponding to response and stimulus events, and our focus is here on this graph, not necessarily these recordings, but this graph here, and this graph, and this graph, and so on and so forth. The device generated a graphic depiction of the rate of behavior, which would be called a cumulative record. So we have the cumulative recorder producing a cumulative record. The graph served as a comprehensive yet simple means of recording, storing, representing, communicating, and above all, analyzing behavioral data. That's by Parsonson and Baer in 1986. And for the first time, the cumulative record provided the experimenter with a continuous visual representation of the behavior in real time, which revealed local, or what's called molecular effects, such as the momentary increase or decrease in responding over time, and molar effects, such as the characteristic patterns of responding generated by schedules of reinforcement. By effects, I mean moment-to-moment changes in behavior as a function of changes in the environment, such as when and for which responses reinforcers are delivered. A major practical advantage of the cumulative recorder over other methods of observing and recording behavior was that measurement was automated. That is, the experimenter did not need to observe and manually record what the animal was doing. So two of the major contributions of the cumulative record to behavior analysis include: one, that schedules of reinforcement would not have been discovered without it, and two, the data generated by the device likely motivated many of the early pioneers in the science who followed in Skinner's footsteps. Cumulative records are now frequently used in applied behavior analysis when a practitioner or a researcher is interested in changes in rate over large periods of time, such as weeks or months, or when how much behavior the learner emits over time is of interest. For example, cumulative records have been used in practice to assess the rate of hand washing, teeth brushing, or bedwetting, and to assess fluency in reading, writing, spelling, and math skills. Alright, it's ASR time. ASR number 1. Who published Schedules of Reinforcement in 1957? A. Skinner and Catania. B. Watson and Pavlov. C. Förster and Schoenfeld. Or D. Förster and Skinner. Give a few more seconds. Alright, and the answer is Förster and Skinner. ASR number 2. The primary apparatus used to study schedules of reinforcement is A. The operant chamber. B. Cumulative record. C. The cumulative recorder. Or D. The automated rate of responding. Give me a few more seconds. Alright, I'll go ahead and close the poll. And the answer here is the cumulative recorder. This is asking about the apparatus and used to study schedules of reinforcement. So you can rule out A, operant chamber, because the operant chamber is also used to study other aspects of reinforcement, or used to even study punishment or the effects of other variables on operant behavior. So it's not quite correct to say, well, that is the primary apparatus. Remember, the cumulative recorder is a device used to automate the measurement of responding that was ongoing in the operant chamber. And the cumulative recorder produced a cumulative record. So the cumulative record isn't an apparatus. It's the product of behavior generated by the cumulative recorder. The recorder is the apparatus. Automated rate of responding is just a characteristic of that apparatus. ASR number 3. In a cumulative record, a flat line usually means A. The animal is dead. B. A high rate of responding. C. Someone forgot to plug it in. Or D. Responding has discontinued. Give a few more seconds. Alright, I'll go ahead and close the poll. The answer here is that responding has discontinued. So I said this pretty quickly. So it's possible if you got this wrong, I wouldn't worry about it too much. I may not have gone into enough detail on this. And the cumulative record, the slope indicates the rate of responding. So when there's a very steep slope, there's a high rate of responding. When there's a medium slope, the rate of responding is moderate, and when there's no slope, that's a flat line, the organism is no longer responding. And so the animal is dead. It's kind of just a silly distraction there. A high rate of responding would be indicated by the opposite, not a flat line, but a really steep line. So, okay. Next, ASR, ASR4. In a cumulative record, a change in slope means a change in A, the rate of responding, B, the experimental condition, C, the absence of responding, or D, the data. A couple more seconds. Alright, I'll go ahead and close the poll. The answer here is A, the rate of responding. ASR 5. How did the cumulative record fundamentally change behavior analysis? Was it A, that it allowed for automated data collection, which freed the experimenter to do other interesting things? B, it enabled objective measurement of behavior which had not been achieved prior? C, cumulative records were easy to interpret and therefore reduced interpretive errors? Or D, it enabled the experimenter to experimentally evaluate the effects of environmental events on the rate of responding. Response patterns extended over time, and their control by reinforcement schedules. A few more seconds. Alright, I'll go ahead and close the poll. And the answer is D. Alright, it is true that the cumulative record allowed for automated data collection. That's a characteristic of the cumulative record, but not its major impact on the field of behavior analysis. It's true that it did enable objective measurement, but there were other methods for objectively measuring behavior before the cumulative record. For example, when Thorndike measuring the latency of cats to escape the box, or Pavlov measuring reflex responses to respondent stimuli. And then cumulative records, whether or not they're easy to interpret, is some aspect. That's a characteristic of the cumulative record, and nothing to do with the impact of the cumulative record or the cumulative recorder on behavior analysis. So D is the best answer here. Okay, that concludes video part 1, and I'll see you in video part 2, and then we'll resume beginning with objective